Okay, so now we are going to prove that the dot product, we're going to relate the dot product to coordinates. So if U is a vector with ij components, ij and k components a, b, c, and v, d, e, f, then we're going to prove that u dot v is a times d, b times e, c times f. And the reason why we're going to do this is because it makes things a lot more easier. If you remember, u dot v is equal to mod u mod v cosine theta. Now, let's say that, remember, we can find the lengths of u and v, but if we're not given the angle, then it becomes a lot more difficult. And with this formula, we just do a times d, b times e, c times f, and we're finished. So onto the proof. A little overview on how we're going to do it is we're going to use mod u plus v squared. We're going to calculate it in two different ways and then equate them to get this formula. So I might calculate it one way and get k, then I might calculate it another way and get c plus d. From this, that means that k is equal to c plus d. And this is how we're going to prove it today. Okay, so I'm going to leave this here and I might come back and reference it during this proof. So the first thing we do is we draw a parallelogram. So this is the first way we're going to calculate u plus v. A, B, C, D. And remember now that, actually let me draw in my three vectors before I say anything. Okay, remember now that we have a angle theta, because we've defined it now, so we can put theta there. Remember, theta is the angle between u and v such that theta is between 0 and pi. And if I draw this, we now know from the triangle rule or vector addition that this is u plus v. So if I draw a line going down and I label this point M, I know that this is theta as well, since these two lines are parallel. If you can't see it, then imagine I drew a line like that, and this one came up at an angle, theta, and this one came up at the exact, and this one is parallel to that line. That means that this is coming up at the exact same angle, theta. If you still can't see it, then I guess a better visualization would be the 90 degrees angle. If this one points straight up and this one is another line is parallel to it, that means that it must point straight up, and the angles are exactly the same. If you can't get it off the those two explanations. Good luck. Okay, so mod u plus v squared if we look at the triangle ACM, then we see that it's equal to the length of AM squared plus the length of CM squared. And I'm not, remember this is a free vector, this is a free vector, this is a bound vector, but I'm not equating free vectors and bound vectors. Once I take the modulus, this becomes a length, so this is length squared is equal to length squared plus length squared. If you look at AM, I'm gonna say it again, you cannot do AM is equal to AD plus DM. We haven't defined this. Vector addition for bound vectors is not defined. So we can't do that. Okay. Now for AM, it's gonna take a bit more, it's a bit more technical than calculating CM, so we're gonna do it on another page. Whoa. Okay, 1. I'm just gonna draw out the parts that we need. Okay. Length of AM. This is just the length of AD and the length of DM. So the length of AD is just the length V, since AD represents V. Since this is a right angle triangle, we can use trigonometry to figure out what DM is. So it's plus the length of cos theta u. Okay. Let me, whoa. Length of cos theta, length of u. Okay, we now have a problem. And the problem is that this is true when theta is in between 0 and pi over 2. But remember, we've defined theta to be between 0 and pi. So we want to make this statement hold for all of theta. If I draw the right angle triangle, the parallelogram, when theta is not between 0 and pi over 2, the line comes down to here, D, A, C. If you now look at the parallelogram over here, if we use this formula, sorry, V, if we use this formula again, it says AM is equal to V, so it adds on V, okay, adds on the length of V, which is the whole of AD, then it adds on cos theta u, so it technically just adds on dm, the length of dm. The length of dm is the same as the length of md, so this is what we're doing. We're starting here, we're adding on v, then we're adding on the length of dm. Since our cos theta is positive and our u, the length of u is positive, we're adding on whatever md is the length. So what we have now is that what we really want is up to am, up to here. Now, the way we're going to do it is we're going to remove the modulus sign, because this is when theta is more than pi over 2, cos theta becomes negative. So now if we remove the modulus sign, what we'll now do is we'll add on v, and since cos theta is negative now, it will minus the second part. So we'll be deleting the md, deleting the length of md, or the length of md, which is the same as the length of dm. So let me recap. So this is representing the length of AD, and this is representing the length of DM or MD. In the beginning, what we have is we add on V, we add on the length of AD, then we're adding on the length of DM, or which is MD, and this goes from here to here to there. I'm just really trying to hammer this in, because this is just like the only really hard part that takes a bit of, I'm not sure if it's hard actually. Okay, so AD, then we add on MD, but what we really want to do is we want to add AD, we want to have AD, and then we want to minus our DM to get this length here. So we remove the modulus sign from the cos, because this situation only happens when theta is more than pi over 2. So okay, that takes care of that, but we do still have another problem. Now that theta can be negative, then, and we want the length of AM, if theta becomes negative, and this is when, if this term is more negative than this term, then our whole thing will be negative. This is when this C is around, it goes past the A, put it around there. So just imagine this parallelogram really, really slanted. I can't really draw it, but yeah, so when this C term is, when M goes to the left of A, then there's a possibility that this term will be more negative than this term will be so much negative that it will make the whole thing negative. So let me try to draw it again. Okay, no. I really want to draw this. Hold on, give me one more. So this needs to come down there. Okay. If I don't think I can draw it with this pen, but okay, let's just go back to this. So the length of V plus cos theta U, this can be more negative than this. This will always be positive since it's the length of V. To compensate for this, because if this is negative, we can't have the length of AM being negative. We add another modulus, so what we now have is cos theta yeah. So AM is equal to this. Okay, I hope that was clear enough. So let's go back. Let's mod. We now have what AM is equal to, so it's mod V plus CM. Okay, CM squared is quite easy to work out. That's squared. So CM squared is quite easy to work out because it's just, you just use this triangle here. So from trigonometry again, so it's sine theta multiplied by u. And then squared. Okay, so okay, we no longer need the parallelogram to complete this. Okay, so now this part here, I'll give you the formula, but then I'll give you an example to show you that it's true. So if you have mod a squared, it's the same as taking a squared. Now let's say that a is negative, then you have, or we take the modulus first, and then it becomes 5 squared. This is the same as just doing minus 5 squared, because this squared takes care of the negative sign. So we're going to use that over here. So we have a modulus of this squared, so we can just square the inside part. So it's all of that squared. And then for the second part, let's just split it up again. So we have mod sine theta, mod u, and it's squared. Remember with the cosine where we had to do the, actually don't worry. Okay, so we have mod sine theta, mod u. Mod sine theta, mod u, and we're squaring all of this. So then what we can do is we can do mod sine theta squared, mod u squared. And we're not going to get rid of the mod u squared here, but we are going to get rid of it. We are going to simplify the sine theta squared part. So if you remember, that was equal to, from what we just shown, from the rule that I just showed you a minute ago. So this is, so mod u squared. Now let's expand out this part. We have mod v squared plus 2 mod v cosine theta mod u plus cosine, we're going to have cosine squared theta, then mod u squared. So I've just, all of this is just this bit expanded, plus sine squared theta mod u squared. And now, if you look at this part, then we can factor out a mod u squared, and we know that sine squared theta is equal to 1. So I'm gonna skip a bit of a step. So we have mod v squared plus 2 mod v. I'll put the mod u there. Cosine theta plus mod u squared. So I just factored out a mod u squared, and then I'll have cosine theta plus sine squared theta, which is 1. So I just have mod u squared. To make this look a bit more presentable, I'll do mod u squared okay, and that's the first way done. So let's go on to calculating it the second way. So the second way is a tiny bit more easier. Actually, it's a lot more easier. So our second way of calculating mod u plus v squared is using the coordinates. So u plus v is just u1 plus v1, u2 plus v2. You know, let me just go the long way. So if u is equal to u1, u2, u3, then u plus v, and we've already proved this, u1, u2 plus v2. Now, to take mod u plus v squared, so I just take the modulus of this and we square it. And if you remember, we've just shown that this works, so we can just use this. I know I haven't proven this, but I'm sure you can find it somewhere on the internet. I don't really want, this video is probably like really long already. So u1 plus v1, u2 plus v2 squared. And now we just do it normally, we just square them. So this is equal to I think the last few steps are fairly simple, so like trying to go through it really fast. Plus and v3 plus v3 squared. Okay. Oh, so long. Okay, so we have u1 squared. We have, I'm going to try to go a quick way. So we have u1 squared, in this bracket we're going to have u1 squared plus 2u1 v1 plus v1 squared. Yeah. and it's going to carry on, so u1 squared plus v1 squared, that's from this bracket, plus u2 squared plus v2 squared plus u3 squared plus v3 squared. Then, now we just need to look at the middle term. So remember, we have u1 squared plus 2 times u1 times v1 plus v1 squared. We've taken out all of the n terms, so now we just do the middle term. And if you look again, I don't really want to write 2 out so many times. Since all of these are going to have a 2, we can factor out like that. So 2 times u1 v1 u3 v3. Okay, should I carry this over to another page? I'll just take the whole thing. Okay, so let's put that there. Handwriting is so terrible. Okay, so if I then put the u's together, I have u1 squared plus u2 squared plus u3 squared plus v1 squared okay, and if you remember, okay, let's come back to this. If you remember from like a couple videos ago, u1, if I take the length of u, and u is u1, u2, u3, then the length of u is just the square root of u1 squared, u2 squared, okay? So if you look back, we have u1 squared, u2 squared, and u3 squared. So then this is just mod u squared. Okay, so now we have mod u and mod v. Mod u squared, sorry, and mod v squared plus 2 u1 v1 plus u2 v2 plus u3 v3. And remember, all of this, to go back to the beginning, was equal to mod u plus v squared. Okay, so now we have two equations in terms of mod u plus v squared. If I just delete this and write them out again. Oops. Okay, so just deleted all the pages. So our first equation is mod u plus v squared was, okay, mod u squared plus mod v squared plus 2 mod u mod v cosine theta. Yeah, okay. And our second equation, which we just got was mod u squared plus mod v squared plus 2 times u1 v1 plus u2 v2 plus u3 v3. And if we equate them, we see that these two terms cancel out, and we have 2 mod u mod v cosine theta is equal to 2 okay. Now the 2's cancel out and we have mod u mod v cosine theta is equal to u1 v1 plus u2 v2 plus u3 v3. And this is the first part. Not sure we've proved. Okay, yeah, we haven't. If you remember from the definition, all the hard parts like done now. If you remember from the definition of the dot products that we use, it's mod u mod v cosine of theta when u does not equal 0, v does not equal 0. When u equals 0 and v equals 0, then the whole thing is 0. So we've proven the hard part. Now we just need to prove that when u equals 0 or v equals 0, then u dot v then u1 v1 plus u2 v2 v3 is also equal to 0. But this, I think I left this till last because it's not really that hard to see. If u equals 0, then all of its components u1, u2 and u3 are 0. So that's 0 times that plus 0 times that plus 0 times that. So that's done. If v equals 0, then we have the same thing. So we've proven it for the 0 case, and we've now proven it for the other case as well. So this holds for both cases in our scalar products definition. And okay, I think we'll stop there. This is probably a really long video.